Hello everybody, welcome to the Henstitute. In this particular video, we are going to take a look at a Newton's second law problem. So I have this situation where a force must a soccer player exert to reach top speed. So if I kind of look at it, it says the soccer player is going to start at rest. That's going to be important. They're going to accelerate forward. They're going to reach a velocity of 8 meters per second in 2.5 seconds. It asks for their average acceleration, and then it says what average force does the ground exert forward on the runner. So she achieves this acceleration, and then the player's mass is given 70 kilograms and air resistance is negligible. So the first thing you should always do is kind of get a visual of what's going on. Whether you draw a picture with your free body diagram with a box, or if you actually draw the person, it doesn't really matter. For this particular case, I'm going to try to draw the person. So here's our soccer player. Go. And if I think of the forces acting on her, we know that there's going to be gravity acting downward on her. So she's going to have a force downward. That's the force of gravity. That's what we call weight. That would be equal to m times g. So that would be 70 times 9.8. We could actually calculate this out. I'm going to go ahead and take 70 times 9.8, and we get 686 newtons. That's how much she weighs. Now, it sounds bad, but newtons is actually probably not the best unit to use for weights. It's just too many. It takes about 4.5 newtons to make a pound, so it's going to be pretty large. But that's not the only force acting on her. The ground itself would also push up on her. So there would be an upward force, what we refer to as the normal force. And is she accelerating up or down? No, she's not. So the normal force would just equal the force of gravity. So it would also equal 686 newtons. It would just be in the upward direction. If you want to get picky, I suppose this could be a positive, and this one could be thought of as negative for a direction. So those two forces are the forces upward. Then when she actually pushes off of the ground, what really happens is she's pushing backwards on the ground. So I'm going to actually draw that as a force that her feet are going to actually push back on the ground. But according to Newton's third law, if she pushes back on the ground is going to push forward on her. But if I got really picky, she's pushing back on the ground with some force, and then what we want is the reaction to that. So she is going to feel a force forward due to the ground. This is that ground exerting a forward force on her. So this is the force, I'll just say a propelling force. I'm going to call that FP. These two are the same. So this force and this force, I'm not actually doing anything with this one. So I'm going to erase this one down here because that force was the force she pushes on the ground, but we're looking at the forces acting on her. That's our free body diagram. And in this particular case, that's a forward force. It says there's air resistance is negligible, so there's no friction forces, there's no air pushing back on her. That's their only force. This is what we're going to be after in part B. We're going to try to find that force pushing her forward. But to do that, I basically need the mass of her, which I have 70 kilograms, and I need to multiply by the acceleration, but I don't know her acceleration. So that's where the other part of this problem pops in. So for part A, we're going to find the acceleration, but look at it this way. So the initial velocity is 0 meters per second. Her final velocity is going to be 8 meters per second, or 8.00, and the time is going to be 2.5 seconds. Hey, look at that. I remember that stuff from chapter 2. That's just our linear motion. And if we think of this all being horizontal or forward, then I can find acceleration using the definition of acceleration. Acceleration is equal to a change in velocity over time. So she's going from 0 to 8 in 2.5 seconds. her acceleration is just going to be found that way. So this is actually a chapter 2 thing. Chapter 2. It's not actually this particular chapter. So I'm going to take 8 divided by 2.5, and she's accelerating at 3.2 meters per second squared. I'm going to write that as a positive, meaning it's to the right, forward, whatever I have for that. There's part A. Now I can come back and I can tackle part B. So part B wanted us to actually find what force is propelling her forward, or the force of the ground exerted on the runner. I suppose you could call that GR, but I'm going to call it FP. It's the propelling force. It's going to be her mass times this acceleration. So we have the acceleration that gets to go in there. We just have to multiply it by 70 because that's her mass, and we like kilograms here in physics. So multiply that by 3.2 meters per second squared, and this should give us our propelling force. Multiply these two times 70, and I get 224 newtons. Awesome. That is basically how you go after Newton's second law type of problems, or Newton problems. So we want to use some of our old chapter 2 stuff, so don't forget about that. So all those old linear motion equations are still available, and then we've got this new idea of F equals ma, that's Newton's second law. But also think about Newton's first, or think about Newton's third, or think about free body diagrams. I didn't really need the weight of her or the normal force because those two vertical forces were equal to each other. She didn't go up or down. We were looking for her forward acceleration, and that's all we had to find. Hope you enjoyed this edition of the Henstitute, in which we solved a problem. Now you should be ready to solve problems on your own.